Okay, then let's start today's class. So today we're going to talk about variable scope and storage classes. What exactly do they mean, right? So in the previous classes that, please mute your microphones, all of you, yeah? So in the previous classes, you have all seen or learned how to declare variables of different data types, okay? And you also know how to initialize them and also use those variables, right? That's been like fundamental now. So all of you know what are variables, how to declare them, how to initialize them, and how to use them, right? So today we're going to answer one question. The question is that can you declare the variables that are accessible only to certain portions of the program? What I'm trying to say here is, can we declare variables so that only some part of the program can use it? That means it is accessible to only a small area in a program. Okay, so
Yes,
we are going to discuss the scope of a variable. Like, can I actually declare a variable which is used by only a small portion of a program? Okay, normally what happens in order to solve a complex problem, right? The programmer, what he does is normally breaks the problem into smaller pieces. And each of those smaller pieces, we try to, write some functions or try to write some code for it. And all these small codes or these functions, we have not yet discussed the functions in details, but we will talk about the functions later on. But these small codes or these modules are put together to form one complete program, and that's how we can solve a complex problem, right? Now, if you go to industry, if you uh, look at the way a software is built, right? It's not built as a single program. You have like different components, small pieces of code, small pieces of functions which are written separately, and then they are integrated together. They are put together to make the complete software. Right. Now, the problem is that when you have a complete program, there could be variables that have to be shared by all the functions. There could be few issues there. There could be a single variable which needs to be shared across different modules or different functions. Right. On the other hand, there could be some variables which should be limited to only that small module, one module or that one function. Right. So the visibility of those variables should be limited. And the values that you assign to those variables in that one function should not be exposed to all the other functions or the other modules. So how can we integrate or incorporate all these kind of scenarios? Right. So limiting the scope of the variables. When I talk about scope of the variables, we're talking about, what is the visibility of that variable, right? Is it visible inside a function? Is it visible inside a small block? Or can I limit the visibility or the scope of a variable to the pieces of code where they need to be used, right? For example, if I'm declaring a variable which needs to be used only in a small portion of the code, and I don't want that to be used in other portion of the code, like, can I do that? So in today's class, we're going to discuss all that. So in C, you can declare a variable and also indicate or specify its visibility level by designating its scope. Okay, so for example, I can declare a variable with a local scope, and if a variable has a local scope, it means that it can be accessed locally, right? Locally means the block in which they are declared, or for that matter, I can also declare a variable globally. That if I declare a variable globally, that means it has a global scope. That means it is available for a larger scope or for a larger, it has a larger visibility. So let's discuss about the scopes today, right? Now the first thing is a block scope. Okay, it's a block scope. Now what is a block scope? A block refers to any set of statements which are enclosed in braces. Okay, which are enclosed in braces. So any piece of code which is enclosed in a brace can be called as a block. So if you declare a variable inside this block, this variable will be available only within this block. What I mean here is, suppose I have a function here, like a main function, right? Now this is a block here, right? This is a block because we are using the braces here. So if I have a variable here int I, this variable int I will be available for this entire block. Okay, now I'm going to change something. Now say that I put another block here, right? Another block here, and inside I write int j. Now this j, the variable which I declare inside this block, this is the first block and this is the second block, right? Now this variable j will be available only within this block. That means if you try to print j here, it will not be available. Okay, so suppose I have a program where I have written something like this. Okay, so I have 3 blocks here. So if I declare a variable I here, this I, because it is present in this outer block, this I will be available everywhere. If I declare j here, this j will be available only inside this block. If I declare k inside this block, this k will be available only within this block. So this is basically a block scope. Okay, this is a block scope. A block scope means that a variable which is declared inside a block is available only inside that block. Okay, now how it is implemented or how that works out, we are not going to discuss that because it requires an understanding of data structures. And just for kind of information, you can associate this with a word called as stacks. Okay, the way this is implemented in memory is using a data structure called as stacks. We're not going to discuss stacks here, but just remember what is a block scope. Now, in a block scope, there can be an issue. What is that issue? Suppose I have main here, and I'm declaring a variable, say some value, let's say 5. All right, and then I write some of my print statements and do a lot of stuff, and then I declare a block. And inside this block, again, I declare a variable I, and I write some other value for this, and I do some kind of stuff, and I close this. Now, if you look at this, this is a block scope, and this is a block scope, right? This has a block scope. Now, there is an issue here. The issue is we are using this I, right, in this block, and we are using this I again in this block. So what is going to happen here? Now, absolutely, one thing is for sure that this I is going to be available inside this block. It is not going to be available outside here. But this I is available for the entire block here. So here we see that there is a nesting of the blocks being done. So this is one block, and inside that there is another nested block. Right. Now in this case, what happens is this I, the value of 5 will be available outside this inner block, right? But as soon as you enter inside this inner block, this I value 7 will be available inside this. That means if I print fi here, I will get 5. But if I print I here, I will get 7. Again, when I come out of the block and I print I here, I will get 5 again. Which means that inside this block, the local I will have the visibility. But outside this block, this I is going to have the visibility. Okay, so inside this block, which variable is going to be visible? It is this. As soon as we exit this block, which variable is going to be visible? This. Okay, so if you have the same variable name, still the visibility actually works in this scenario. That means this I will not be visible inside the nested block. So are you able to understand what I'm trying to say here? Can I just get a response from you saying that are you able to understand or not?
Yes, sir. Yes, sir, completely.
Yes, sir.
Completely. Okay.
Clear,
Okay,
sir.
good. Okay, great. So this is basically a block scope. All right.
Yes.
Now if you look at, let's talk about a program scope. Let's talk about a program scope. So when I write my int main function, right? So any variable that I declare inside this is basically a block scope because here is my, braces, right? So I can write int I here, right? Or I can declare another block and inside that I can declare another variable j here. Okay, now all these have block scope, right? Now these variables which have block scope, that means they are available locally, local to these braces, right? These variables are called as local variables. Local variables. That means these are temporary variables. Okay. What is the meaning of temporary variables? That means they exist locally. That means inside this bracket they exist. The j exists, but as soon as it comes out of this bracket, the j does not exist anymore. Okay, so these variables like I, j, these are called as local variables. Now, this is a very common term that you will hear across programming. Local variables, okay? And now, let's say here is my main method. I can also declare variables outside the main. Outside the main. That means I can declare it here before we write the main function. So I can write a variable here, like say x is equal to 10. I can declare a variable here. So I'm declaring a variable x and initializing it with the value 10. Now this variable does not have a local scope because it is above the main, which means that this has a program scope. What is the meaning of a program scope? It means that when we are declaring it outside the main function, right, this variable will be available for the entire program. That means it will be available outside the main, it will be available inside the main, it will be available in all the different blocks, it will be available in all the different pieces of your program inside one program. Okay, so such variables which are declared out of the main, right, they have a program scope. That means they are visible for the entire program. They are not visible locally for this block or for another block, but they are visible for the entire program. So such kind of variables, right, the variables with program scope are called as global
Global
variables.
variable.
Yes, global variables. Okay, so these two are very, very commonly used terms, local variable and global variable. Okay, so global variables are those variables which are declared outside the main. Okay, they have a visibility for the entire duration of that program. That means they are visible or they are available for the entire program. But a local variable has a local scope and it is visible only in a for a short period of time. That means it is a temporary variable. Local variables are also called as temporary variables. Okay, now this is a concept about local and global variables. Okay, so in C, we have something called as a storage class specifiers. Okay, storage class specifiers mean that it's basically nothing technical, but it's just a term given for a variable using. There are certain specifiers. When you talk about specifiers, that means we use some keywords. So let me just get to the new screen. So when we talk about storage classes, are nothing, but you can declare variables with some keywords. These keywords basically specify the spatial region of the variable. What is the meaning of spatial region of the variable? That means where the variables will be stored and for how long that variable will be available. Now, before we actually understand the storage class, let's discuss about the memory again, how the memory is organized. Now, in one of the classes which we did not recognize, it was just like interaction classes, I gave you a brief introduction on how the memory is organized. So let's bring that back to this class. So how is the memory organized, okay, behind the scene? So here is my memory. So when you do your program, when you write your C programs, right, everything is organized into memory. That means your code is stored into the memory. The data that you actually, for example, if you declare a variable, initialize the values, it is stored in memory. So what the compiler does is the compiler partitions your memory into different segments. Okay. So how is the segments partitioned? So first of all, your memory where you store your code and your data is first partitioned into two parts. Okay, so the first part is called as your data segment, and the second part is called as your text or code segment. Okay, so what is stored in the text or code segment? Now, when you write a piece of code, each line of your code represents a instruction, right? Each line of your code, print f, c is equal to c plus 1, for I is equal to 0, or blah, 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 while, do, everything that you write one after the other is basically a instruction. And all these instructions are stored in the memory. Okay, they are stored in the memory. Which part of memory? They are stored in the text or the code segment. All right. And after that, when you declare something in the code, for example, this line says int x, okay, or this line says float y. Now, these are again, a part of instructions. That means int x and int y. These two code will be stored somewhere here. But when you initialize or when you declare or the memory location for this, when it is allotted, that means if the variable x, when the x is allotted a memory, then this is stored in the data segment. The value 5 or 6 or 7, whatever these values which you initialize to this variable, these values are not stored in this segment, but they are stored in the data segment. Okay, are you able to understand this much? Because this is an important topic that we are discussing today. So can you just give me your response before I can move?
Yes, sir. Yes, sir. Continue.
Yes, sir.
Okay, fine, great.
Continue, sir.
Right. So again, this data segment is divided into different partitions. Okay. So the data segment is divided into 3 different partitions. All right. Now, one partition is called as the stack. Okay, one partition is called as a stack. The second partition is called as the static. And the third partition is called as the heap. Okay, so these are the 3 different partitions of the data. Now what happens? So which variables go here, which variables go here, which variables go here? Now that's the question. Okay, now the first point that you must remember is that when you have a local variable, all the local variables are initialized into stack. Okay, local variables are initialized into stack. The global variables are initialized into the static segment. So in the previous example, you saw that these were local variables. So where will the value of I and j be initialized? The value of I and j will be initialized inside the stack segment. We had a global variable x. Where will the value of x be initialized? The value of x will go into the static segment. Okay, now this is a rule. All right, so this is fine for global and local variables. That we understood. Now, other than that, we have something called as a storage class. Okay, now the storage class has got certain keywords. Now, you can specify or you can define where your variables will go in these memory segments, using some keywords which has got some meaning. Okay, so there are 4 different specifiers. Okay, 4 different specifiers. So I'm going to just write those specifiers first. So you have the auto specifier, then you have something called as a static specifier. Okay, static specifier. Then you have something called as register, and you have something called as extern. Now I'm going to discuss these 4 storage classes. Now what do these 4 storage classes or these keywords? They are also keywords in C++. Okay, so it means that I can declare variables using these 4 keywords. Okay, I can declare variables using these 4 keywords. So basically, when I'm declaring a variable, normally I declare it as x. So I can write auto here, or I can write static here, or I can write register here, or I can write extern here. Okay, so I can declare variables with one of these 4 keywords. So we'll try and understand what exactly happens when you declare variables using these 4 different keywords. Okay, so let's discuss that. First thing, by default, when you declare a variable, a local variable, right? By default, it has this keyword auto. Did you understand that? So when I declare X, a local variable which goes into the stack segment, this by default has this storage class or this what do you call keyword auto. So if you write auto int X and if you don't write auto int X, it means the same, because if you don't specify any storage class, if you don't specify any specifier, okay, by default it is taken as auto. So we know auto means what will happen to the variable? It will be stored into the stack segment. Okay, and what is the characteristics of this variable? The property or the characteristic of this variable will be that it will be stored in a temporary memory location, which is a stack segment, and it is a local variable. That means this variable will not be available for the entire duration of the program, but it will be available only for a short duration, for a temporary duration. Okay, so it will be available inside that block only. It's a temporary variable. Okay, so I hope everybody's clear with this. So auto is nothing but same as, you know, int X. By default, it gives the specifier auto. So if you don't specify anything, by default, it takes it as auto. Okay, so auto is kind of clear. Now the second important question is static. Now what happens with static? So when you declare a variable, so if I declare int X and I declare it as static, now what happens? This variable will be stored into this segment. Which is this segment? Static segment. Now what is the property of the static segment? Now the property of the static segment is any variable which is stored in this part of the memory will remain in the memory for the entire duration of that file. That means if you have a file, right, and you store a variable in this segment, this variable is not temporary, but it has a scope of that file. That means if you write a C program, and this variable will be available for the entire file. What I'm going to explain it again to you. So suppose I write my main method here, right? And suppose I write int I, okay? And then inside here, I am declaring int j. Okay, then I'm writing some pieces of code here, and then I close this, this main method. Right now, where is this I going to go? So I have a memory location here. So let's say this is stat and this is static. Okay, so this is my stack segment, and this is my static segment. Now the property of the stack segment is that variables which are present in the stack segment do not remain for the entire duration of the program, but it is a temporary variable, so it is stored as a local variable temporarily. So this I is going to go into stack, this j is going to go into stack. So as soon as the program execution comes out of this block, this j will be deleted from the stack memory. Okay, so once it is deleted, it will not be available here, right? So this is the property of your auto or the local variable. But when you declare j, now this j is not available in this part of the code because it is a local variable and it is stored in the stack segment. But if I declare it with this keyword static, with a storage class static, right? What happens is this variable j is no longer stored in this now. It is not stored in the stack segment. Where is it stored? It will be stored into the static segment now. Okay, so now j will be available in the static segment. What is the property of the static segment? Now, any variable which remains in the static segment or it's stored in the static segment, it remains for the entire duration of the file. That means this has got a program or it has got a file scope. File scope means if this is your .cpp file, this entire, so here your file ends, right? So this is the point where your program ends and your file is completed. So this J will be available inside this block, and now this J will also be available outside. That means till the last line of your program, this J will be available. Okay, so just by putting a keyword static, this J will, the scope of this J will change. That means this J will no longer be available only in this block, but it will be available till the last line of this program. So if I declare another static K, this K will also be available till the last line of the program. Are you able to understand this?
Yes, sir. So just a
Yes, sir.
doubt.
Okay.
Sir,
Okay.
sir,
These are, yeah. So these
can
are
you hear
very
me, sir?
important. Yeah, I can.
So just a question. Hello.
हाँ बोलो रहमान बोलो
Yeah, I can hear you. Come on.
Yes, sir. Sir, by putting static, is there any changes occurred in program except like storing capacity? Any other changes, sir,
No, storing
normally held in
capacity.
program?
No, capacity is not changing here. Please
No, no,
remember.
no. Like, yeah. Putting static, like J will gonna store in static. So
Yes,
that's
you're
clear. Apart from that, any changes happened in the code
Yeah,
or?
the changes which is happening is that this variable will be available in here now. It will not be available only inside this block, but will be available for the entire duration of that program. That's it.
Okay, sir.
So that means if you declare a value of j is equal to 10, even after you come out of this block, you can still print j is equal to 10 here outside, because j will be available here. There are two important things you must understand. If a variable exists in memory, you can access it. Okay. If you have something in memory, you can access it. If you remove it from the memory, you can't access it. Okay, so till a variable exists in the memory, you can access it. So when you store, when you store any variable or any value in the stack segment, it is kept only for a limited time. It is kept only for a short duration of time. Okay, so as soon as you come out of this block, this variable is deleted from this memory. That means it is not available. So if a variable is not available, you cannot access it here. But in static segment, what happens is this variable will not be deleted after you come out of this block. So that is the fundamental difference, what is happening, or the changes which are happening behind the scene. So when I declare something as static, that variable is kept in a different area where that variable is not deleted. Did you understand? So if it is not deleted, I can access it from other parts of the program also.
Sir, same thing also can be happened if I globally declare the value of j.
Yes. Now,
So
I'm coming to the global variable. Now, what is the difference between a global variable and a static variable? That's my point.
yes, sir.
So, the first point is, when I told you that when you declare a variable as a static variable, this variable has a file scope. File scope. What is the meaning of file scope? File scope means it is available for that file. For the entire file, it is available. Okay, so the next question is, what is the difference between a global variable and this variable then? What is the difference between a static variable and a global variable? Because, when I declare it as a global variable, it is also available in the entire file, right? And if I declare it as
Yes,
a
sir.
static, it is also available in the entire file. Now, what happens is, suppose you make a software, and inside the software, I have got 4 different files, right? So here are my 4 different C programs. So this is 1.c, 2.c, 3.c, 4.c. These are my 4 different C programs. Okay. Now, if I declare a variable as local, let's say if I declare a variable as a local variable, it will be available only for a small part of one file. That's clear. If I declare a variable as static, it will be available for the entire file, right? But if I declare a variable as global variable, it will be available for the entire file. Also, you can access this variable in all the other files as well. Did you understand this? So,
Yes, I got it.
a static variable will be accessible only to that file where it has been declared as static. But a global variable will be, if you're declaring a global variable here, this global variable will be available in this file, and this file. You can access it in all the other 3 files as well. So this is global in nature. Static has a file scope. Global, the scope of global is even, it's got a higher scope. It's got a larger scope than a static variable. So did you understand this? What is the difference between a static and a global variable?
Yes, sir. So in multiple functions, we can declare multiple static variable.
Yes, you can declare as many static variables, but I'll again, fundamentally, when you should be declaring it as static and when you should not be declaring it as static is another question. So that it's basically a design question. So one day I'll cover that. But for now,
Okay.
just understand that a static variable, when you declare a static variable, it is available for the entire file. A global variable is also available for the entire file, but along with one file, it can also be accessed in another file. Okay, so
Okay.
that is
Thank you, sir.
basically a global variable. Now let's come back to the place where we declare these 4. Let's bring that to the next page. So we talked about auto, static, register, external. These are the 4 storage classes. What are the storage classes? Auto, static, register, and external. So out of this, we know what is auto, right? By default, everything is auto. That means it is stored in the stack segment. We know what is static. Okay, static is stored in the static segment and it has got a file scope. That means this variable will be present inside the memory, or it will be stored inside the memory for the entire duration of the file. All right. Now we will talk about extern. Right. Now extern is a keyword by which you can access a global variable in another file. Okay. So extern is basically a keyword through which you can access a global variable in another file. Let's say I have 1.c. So this is my file, right? In this file, I have declared a global variable. So if I declare a global variable means here is my main method, and outside the main, I have declared int x is equal to 10, right? Now this is my global variable. This is my global variable. Now, how can I access this global variable in another file? That's my question. Okay, so in another file, what I need to do is I need to use this keyword called as extern. Okay, so how do I use it? So suppose this is my 2.c. This is another file. In this file, I have written some functions or whatever it is, and I need to access. So if I write int y, sorry, I have declared it as x. So if I have to access this global variable in another file, I will be accessing it with an extern keyword. extern. Okay, so I will, if I declare this extern int x, okay, if I write extern int x, now this int x will not be allocated a memory. That means there will be no memory allocation done for this int x. What it will mean is that I am accessing a global variable which is declared in another file. Okay, which is declared in another file. So here is the actual memory allocation being done. So when I declare a global variable here, this x will be stored into a memory segment, right? Into memory, which is that static segment. Now already the x is stored here. That means the value of 10 is here. So in another file, when I write extern int x, this extern keyword tells the compiler that look, don't do any allocation for x, but this x is a global variable which I'm accessing in another file. So this x will be accessed in another file. Now, if you have to use this global variable in another file by using the extern keyword, then it's important that you compile both these files together. Okay, so you can compile 2 files together in C. So you can compile multiple files together in C, because when you make a software, when you make a big project, you will be having multiple files, and all those multiple files can be combined or compiled together. Okay, so only in that scenario, your extern will be used. So if you are declaring a global variable in one file, you can access that global variable in another file by using this extern keyword. Is that clear?
Yes, sir.
Okay.
Yes, sir.
Fine.
Yes, sir.
So we can do some small programs in this. Okay. So I will, I'll try and give you, or you can try your programs, or I'll give you some small programs or snippets which you can try. The reason is we can't do a lot of programs in this particular class is because this is a theory, fundamental theory class, right? So I have to cover up a lot of topics because if I go program, it'll take up a lot of time. So, but still, we'll try to, once we finish the syllabus and we will have some time. So during that time, I will give you lots of programs to practice and then we can discuss one by one. Okay, so first important thing is we need to cover the syllabus that we actually have. That's more important. Okay, so you know what's auto, you know what's static, and you know what's extern. Now what remains is register. All right. Now what exactly is this register? So in order to make you understand this, I need to, talk to you a little bit about a processor. Okay, now you know what happens when you actually run the code, when you run programs. See, what happens is, here is your program that you've written, right? These programs, now what I'm saying is these programs are written in, say for example, your high level language, it is converted into machine level language and whatever. So finally we have a machine level language which is stored into the data segment. Sorry, which segment? It is a text segment, not the data segment. Okay, so this machine level code is stored into the text segment. All right, so everybody is clear with that. All right, the next thing that I'm going to tell you is how are these executed?
सर
How,
रजिस्टर नहीं समझ में आया.
I have not yet told you. मैंने अभी तक बताया नहीं है. मैं explain कर रहा हूँ. Register पे explain कर रहा हूँ. Okay, I'm explaining register right now. So just be patient. Now what happens is, this each set of instruction is basically, from the RAM. Now this is present in the RAM of your memory. This is your CPU or the processor. Are you? Am I audible to all of you?
Yes, sir. Audio.
Yes,
Sir.
sir.
Fine, fine.
Yes, sir.
Now what happens is, you know that when you are trying to run any program, suppose you want to run Photoshop or you want to open Microsoft Word or anything like that, what happens is all the programs, all the files which are present in your hard drive, right? So here is your hard drive. This is your hard drive. Okay. So all the files which are present in your hard drive, when you run anything, any software or any program, even a C program or a C++ program or a Microsoft Photoshop, Microsoft Word document or anything, these are first loaded into the RAM. Okay, these are first loaded into the RAM. All right. Now, because you must have noticed that it takes time for that program to open up. So what's happening is sometimes you'll find that there's a line which is, a lot of files are being shown that they are being loaded. One by one, these files are loaded into the RAM. So once it is there in the RAM, it is ready to run. That means you are ready for processing. Okay. Now what happens when you are processing? Now RAM has got some memory, right? You have 8 GB RAM and 6 GB RAM and 12 GB RAM and 14 GB RAM. So RAM has got some memory. But each of these instructions has to be executed or processed where? Inside my CPU. Inside my CPU, right? Inside my processor. Now what happens is, how is it processed? So depending on the type of processor I have, like sometimes that we talk about a 16-bit processor and a 32-bit processor and a 64-bit processor. You've heard about these three different sizes of processor, right? So we have 64-bit processors which are very common now. What it means, what do we understand by this? Now what we understand is, if you have a 64-bit processor, okay, that means this processor is able to process an instruction which is of size 64-bit. That means, for example, if I ask you, let me give you an instruction. The instruction is go out, okay, and get a glass of water and close the door. Now this is an instruction, right? This is an instruction. So my instruction is go out and get a glass of water and close the door. Now suppose this instruction is say 128 bit. 128 bit. How? Suppose you count the number of words. I'm just assuming, okay, it is not exactly 128. Suppose it is 128 bit. So I cannot execute this entire instruction in a processor. I cannot basically process this entire, instruction at one go. Because if my processor is 64-bit, I cannot process a 128-bit instruction. So all these are instructions which are stored in the text segment. So what is done? One by one, these instructions are taken to the RAM, taken to the CPU. They are stored into the CPU memory. The CPU memory is either 16-bit, 32-bit, or 64-bit, and then it is processed, and then it is returned back. Then the second instruction is sent because CPU has got a very limited amount of memory, either 62-bit, 32-bit, 16-bit. So your RAM has got huge space, 8 GB, but your CPU still has 64-bit, right? So what is done is these instructions are broken down into smaller instructions, and each one of them are executed one after the other. So if this is a 64-bit instruction, and if this is a 128-bit instruction, and if my processor can handle only 64-bit, then what is going to happen? I have to break this instruction into two parts. So suppose go out and get a glass of water is basically one part, and second one is and close the door, right? So what I'm going to do is I am going to first send only one part of the instruction. So I will tell you, go out and get a glass of water. So you go get the glass of water, and then I will give you the second instruction when one is completed. The second instruction will be close the door. So what is happening is I am getting these complete instruction executed in two parts. So first I will give you one instruction, and then I will give you the second instruction. So are you able to understand what I'm trying to say here? So suppose I have a 16-bit processor. My processor is only 16-bit. So now it can't actually execute even this, this instruction into two parts. So what I have to do is I have to make smaller instructions for the same thing. So what I'll do is first I will tell you this will be one instruction, go out. So first instruction will be go out because it's a 16-bit processor. Then I will tell you get a glass of water. And then I will tell you close the door. So I have to break this one instruction into three smaller bits. That means some three smaller bits which are less than 16-bit of size. Okay, so this is how the processing of each of your instruction is done in the CPU. Now, when you are taking the instructions, along with the instructions, you're also sending the data. Suppose there is an instruction C is equal to A plus B. Now, along with this instruction, I also have to take A and B value inside here and store it into these memory. Are you able to understand? Can you give me a, all of you can understand, right, what I'm trying to say here? Okay. Now what happens is this data is carried into this, what you call, along with the instruction, the data is also carried into the processor. And this data is stored into one of these bits in a processor, right? And then it is evaluated. It is evaluated and everything is sent back to the RAM. Again, this instruction is carried into the CPU. Another instruction is carried into a CPU. And again, the data along is also carried. Now, what happens here? It's very important to understand what happens behind the scene. Okay. Now, what happens is, suppose you have a variable. Suppose you have a variable I. Okay. So, with the first instruction, I is being used. Second instruction, again, C is equal to C plus I. Third instruction, you have I plus plus. Fourth instruction, you are printing the value of I. Now, what is happening is, when you are sending these instructions one by one to the processor's memory, right? This I is being sent and again it is being sent back. Again this I is sent and again it is sent back. So this I is sent multiple number of times to the the processor, and this I is again sent back, right? So since this variable is used multiple number of times, that means the same value is being carried to the processor memory and again it is being returned, again it is being carried by another instruction, again it is being returned. So in order to speed up the process, if there is a facility by which we can permanently or for the some duration, if I can store I here itself, right, what will happen is that when we are sending an instruction to this processor, I need not go, to the processor many number of times, so in order to stop this redundancy of I being taken to the processor again and again and again, if we can keep this value of I here till all my instructions are executed, then my program will become little faster. Are you all able to relate to it? Are you all able to relate to it? Yes, I'm just waiting for a response.
Yes, sir.
Yes, sir. Okay, good. So what I do is, if I declare this I as a register int I am giving an instruction to the compiler that when you are sending this I to the processor, keep this I in the processor itself. Okay, so register int I, when you declare any variable with keyword register, that means you are giving an instruction to the compiler to store this I in the memory, that means in the processor's memory, right, till all my instructions are executed. Now there are advantages and disadvantages of this. The advantages is this I value need not go to the processor with every instructions, right? Because I is used many number of times, so I will keep I in that place itself, in the processor's memory, right? So I will send all the instructions one by one, but I value is there all the time to use. So what happens? What happens is it speeds up your processing. You're not carrying one extra data all the time here and there. So I is always there. So it increases your processing speed. That means you can make your program run faster. But the drawback of this is, if you declare too many variables as register, then anyway your processor has got a limited memory to process your instructions. So if your processor is 16-bit and if you are declaring 3 integers as register, then half of the memory of your processor is being taken up by these 3 register variables. So what is going to happen is your instructions are actually going to get slower, because now you cannot process larger instructions. You can process only small instructions now. So there is a trade-off. So when you use register to declare any variables, right, you just request the compiler that please, because, and when you should use register, you should use register because this variable, if this variable is used multiple number of times in your program, that means it is used all the time. If it is used only once, then you should not declare it as register. Okay, so if your variable and you should not be declaring all your variables at register just to make it faster. Only one variable should be declared as faster or as register, 1 or 2, because it occupies a space in your processor for a longer duration of time. So it's basically going to reduce your instruction size. So register should be used if one of your variables is used rampantly in your program. Okay. Also, when you specify this storage class as register, it does not give you a guarantee that this variable will be stored into the processor's memory. It is just a request to the compiler. Depending on the processor, depending on the compiler's capability, and the compiler will make a decision whether the register should be taken or stored into the processor or it should not be. So this is just a request to the compiler. It is not a compulsory thing that the compiler will do. So when you declare a variable as register, you are requesting the compiler to allot this variable in the processor's memory. Did you understand this?
Yes, sir.
Okay, so we discussed about auto, and remember one more thing. Okay, remember one thing. 1 second, let me write it down. Static and external. Okay, remember one more thing. This register, when I use register, it has to be a local variable. Okay. Okay, you cannot use these as register. So when I declare any variable x as with a register keyword, please remember that this has to be a local variable. So auto and register are almost the same. One is stored in the stack and the other one is requested to be stored into the processor's memory. So processor's memory is requested. If it doesn't, if the compiler does not accept your request, then this will be stored into your stack segment itself. So in the stack segments, all the auto declared and the register declared variables will be stored. So if the register declared variables are not stored into the register of the processor, then it will be stored into the stack segment. So your X, which is declared by register, should be a local variable. Okay, so we discussed a very important and very important concept in programming: the memory, the scope of your variables, and the storage classes. So the storage classes are basically these four storage classes. Very important. What is static? Static is very important. Now, if you go for any interviews, placement interviews, job interviews, they will definitely ask you about these four. And what they will ask you is your conceptual knowledge. Most of the books that you read, or most of the teachers will teach you, they will not teach you the concept behind it. They will not connect you to the memory. They will just tell you what happened in the program if you declare it as auto, register, static, and external. But the behind the scene is very important for these four because it's very conceptual. So I hope all of you have understood today's concepts very clearly, because it's important from your future perspective, from your placement perspective, from your job perspective, from your master's perspective. It's very important. Okay. So with that, we can close today's class. Now you can start giving your attendance.